All right, so we're gonna go through the next session about particle picking. About this. All right, so we're gonna focus on those three data sets. Trying different manual picking, different picking method. So we're gonna go through manual picking and size-based picking and geometry-based picking for varying data sets, and also the neural network method. Well, here we're going to try the neural network picking on the 10 and 87. Okay, here's a data summary. First, we're going to try the manual picking. So the data sets we were going to work on will be like Ampere data sets 10 and 87, which is this one. We can open the preprocessing panel, where we go to the Q series reconstruction button here. I really can see this tomogram slices. We can make this a little bit smaller because we don't really work on these two side view projections. We only mainly working on this top view. So you can go through different slices, right, to see the particles. Here we're gonna pick the manual the wrap sums for manual picking. Okay. First you're gonna do this create a new job manual list, like where you save the manual pick coordinates with a name. So click this new button. It should pop out a window. You can name it as manual list. So this name or this file will store your coordinates where you manually pick the particles. Create. So here, this particle list will update as the new create list here. So use your left mouse click button, go through all those slices. When you find a good targets like a wrap sum, let's say this one, click it. So there's a circle will be labeled that wrap sum coordinates. So the circle radius will be like a default radius right now because we didn't set any of the information about the radius. So it will be like a small circle around it. So there's a kind of a more convenient way to control this slice. So you can use the, in your keyboard, you can use the left and right arrow to go through different slices of these tomograms, right? If you notice the center, maybe yeah, this one, the center of the wrap sums, when you go through the different slices, then you could pick that position. We can add more. All right, so this will automatically save all your manual pick coordinates into this file name. You won't be able to open this file name on the web interface, but it was saved in like a in the background, like you can now access from the interface. Well, of course, sometimes you work in a different like different method of the picking. Like you want to know the targets or the protein size. So here's a ruler in this panel. You can open it, and you can measure it. The particle size. Here will be like, oh, it's like maybe 214 angstrom, but it may be very close to the wrap sum size, but probably we need to go through, right the center of the particle. We can try this one. Right. Oh, it's much smaller. It's not that easy to measure kind of small molecule here. Like probably more useful to measure a bigger one. Here later we're going to show how we measure the variation size. Right. All right. So we can pick more positions here. All right. Okay. So we pick certain positions for manual pick. If you want to do the like mostly we won't do the manual picking for all the data sets, right? So the main purpose of the for the manual picking, we use it for the neural network pick training as a start. So of course, there's other several different options here, like copy, delete, and load. So the copy is like you can make a different name, copy this file name with a different, with a different, copy this file with a different name. Let's say like a manual pick, maybe test copy. Yeah. So here you can notice that this test copy updated in a particle list, right? And we also could delete this new copied one. So here you're going to show that ask you want to delete this file or not. So we can do that as yes because we have duplicate ones. Now we don't see any particles here because we delete that list in the current display. And we want load the previous one like we originally created the original one. So load. So the load will show several different options. The auto particles, auto variance, which is not involved in this data sets. The auto particles, when you run the set space or like some other automatic way to do the particle picking, there will be a list in this auto particle. But here we didn't run anything. It's empty, so we don't use it. And this is the one we just created. So just load this one. See that everything we picked showed up again. Now you can use this list for the neural network picking training. So we're gonna go here. So we still use this data set as an example to show how you specify different parameters for the neural network picking. So first thing we need to check, once you load this minor list, you verify all the picking positions looks good. You can go back to the main panel and go to the edit, where you can change the parameters of this pre-processing block. So the neural network picking method mainly in the panel training evaluation button, right? Okay, click this button here. We're gonna change several different parameters in this panel. So the first thing is that we're gonna use the manual list we just created as an input for the training, right? So here at the top of this panel, there's a select list of positions, which means you can load the particle coordinates you just created, or any particle coordinates you have will show up here. See here, like a manual list, right? Loaded. So that means the neural network picking will take this input as a training start. And the next setting you're going to change is in the particle detection panel. You give it a radius where we just measure a little bit, but yeah, here's a radius. We measure the dimension, so just half of the size. But maybe some people already know for like eukaryotic ribosome, they should be like a 260 angstrom, but we can use kind of smaller size because for particle picking, it's really like the boundary of the particles is really not that strategically matching the real size. So 80 angstrom should be worked for ribosome as a radius. And the next setting you need to change is the detection method, because here we're going to use PYP train, which is a neural network training method. So that will be done. And go back to the training evaluation. We're going to set several other parameters to make it properly for this data size. So the first one is the bounding box. So this bounding box is the voxel size against like in the beans tomograms, how many voxels ribosome or like the protein that you want to pick occupy in that tomogram. So here we're gonna cite as 12 voxels. And the other very important parameter we're gonna change is the max number of particles. So this basically is some kind of estimation. Probably you're gonna go through several tomograms from the density visualization in the reconstruction panel to estimate the possible particle numbers from tomograms. Of course, here we want the max number of particles. We're gonna set 600 for this data set. The other parameters we can click this show advanced options, right? And we can leave it as default. So right now we don't need to change because it won't affect too much, but usually we just leave it as default. If you want to play around, different settings and achieve different effect or results, you can try it. But here for this practice workshop, here we won't change any of those default values right now. So the resources for the training, nextPYP use GPU, prefer the GPU because GPU is much faster for the training network. But so we are not really like use GPU for this workshop. So we just here we won't really run it. I just show you how you're gonna change those parameters to run for your future work. So right now we just save the settings and everything we just set up. And the next step, say you already run the training, you can have a results like trained model from this procedure when you finish the GPU job from the training procedure, right? So the next thing you're going to do is use the trained model to really pick the particles across all the tomograms, or the whole data set, I guess. So the thing you want to do is pretty simple. So go to the edit again. Go to the training and evaluation. Here, this trained model is where you're going to load the trained model from the previous training job, where we didn't run, but we already put the pre-trained model somewhere in the workshop folder. So we're going to find it. Seeing you can click this button, I think. It's like the first button, garage button, I guess, icon. Go to the nextPYP workshop. Go to the 10987, which the datasets we were working on. And you should see this model last contrastive PTH. This is the trained model results, usually the name you have from the training procedure. So select it and choose a file. you're going to see that this file loaded properly. That's basically the only thing you need to do. So resources, you don't change anything. We just use the previous setting for the CPU, because here for the picking, we just we call it evaluation using the pre-trained model, but generally just picking all the data sets you have. So we're gonna save it. Yep. Once the settings are ready, we can run it. Here, please ignore those other runnable blocks, because we don't want to run it right now. Just click this, the second button will clean all the runnable blocks you don't want, right? So this is the only one. These six probably a different thing you have. You just need to pay attention the name, pre-processing, right? This one we want to run from 10987. So make sure that's the one you're gonna run. We're gonna start run for this block. So you will run pretty quick. Should be like a few minutes to finish. We're gonna see this results later. All right. So while this is running, we can go through the next thing about size-based picking method. Okay. So the size-based picking method will focus on this as 10499, which is a bacteria cell, the ribosome inside the bacterial cell. So the settings you can change for the size-based picking. Of course, we can actually open this preprocess job and then have a look at the particles, right? Like how they look like and what kind of particles we should pick and the size. We just measured the eukaryotic ribosome size. The bacteria ribosome size may be a smaller size compared to the eukaryotic ribosome, but they should be pretty similar. We can try to measure it here, actually. Just left click and then release, and then left click the next point. Well, T56, maybe very close to the real size of the bacteria ribosome. But for the real picking, maybe it's not actually we want to use, because the image is different from the real size when you open the structure of the ribosome. So let's find a central section to measure it again. We can try and measure this one, I guess. Was this okay? 132, maybe 140, something like that. This one. 150, 160, okay. Yeah, with this way, we have some kind of feeling about how big is the ribosome we want to be. All right. Of course, we want to, we could look at this side view. So how you're going to see maybe some kind of contrast distribution of this sample. Where is the reconstruction, the main sample signals are located. So basically use for this tomograms, you're going to see most of the cell or real sample is located in upper slices, right? Because you see some volume here, there's no really contrast there, right? Maybe you also could go through different slices, see there's pretty much empty here, right? And later you're gonna see some real signals. And once you go to the end, there's also empty. We can choose another tomograms, which is when you see the side views, you can notice like most of these signals located at the center of the section, right? So this part of the contrast is mainly here in the middle. Also in the other side view, also maybe similar position, like most close to this middle. if you go through different slices, also same situation, like to the start, there's no any all features. And in the middle, you can see some features of the style. To the end, yes, also like nothing there, right? So keep in mind, so this is how like use the information we have now to setting the size-based particle picking. Or maybe also there's other method. You also can use this kind of information also. Oh, what's wrong with the train? You can load once you found you notice that there's something wrong. You can open the log. Maybe okay. Sorry, there's something wrong with the no resources again. Let me check again. Oh, I made a mistake, I think. We didn't change the method here. Sorry, we're gonna go back to this again. This particle detection method, since we didn't run the training, we need to do the change the detection method as the evaluation, which is the one we want. Sorry about that. Now save the parameters. So I really pay attention to this. Like we need to change the detection method as a train PYP evaluation. So that way you really do using the pre-trained model to do the particle picking. All right, save it. So probably this example that you want resource of GPU, but there's no available resources, and it will give you an error. Yeah. All right. Run this again. Clean other you don't want. Only this. So run it. Okay. Now we go back to the size-based picking again, which is 10499. We just go through the how you're gonna prepare all those information from the tomograms vision panel and setting the parameters properly to do the size-based picking. All right. So we're gonna go to the edit, do the particle detection panel parameters, where you set the detection radius as 80 also, because rhabsums they are pretty similar. So this time we're gonna change the detection method as auto, which related to the size-based. So the auto name is the size-based method you're gonna use. So we just look through the tomograms, check the distribution of the signals from different slices. So we have a feeling about how most of the signals come from which slices they should be, right? There's a parameters in this particle detection panel. It's a z-axis detection range, which pretty useful. You can control which slices you want to pick, well, you want to pick particles from, right? So this is basically a way to control you won't pick particles or some noisy signals from slices that really empty, because tomogram reconstruction you won't be able to control like only focus on the sample. You probably the sample is going up and down. You have some void volume or like signals in the tomogram reconstruction. So you can limit these slices to only focus on the real sample. So this we're gonna change to 80. So this the 80 slices means like from the center of the tomograms, you go up 80 slices and go down 80 slices to pick those particles around this range, which means like 160 slices. You probably remember that in the vision reconstruction panel, you see the slices 128 slices, but the actual tomograms is 256. Here is 160, should be able to mostly focus on the center of 160 slices. Because we've been in the tomo slices in the vision panel as two, been in two, so you only see like 128 slices from real tomograms of Z slice like 256. All right. So we set up this parameter, and another parameter we're gonna change is contamination mask dilation. So this we're gonna change 20, which gonna pick more particles. And the minimum distance between the particles, which control the how much how much close of two coordinates to each other. If you use a larger value, means those coordinates should be separated away more further. We're going to use 2, which is twice of the size of the particle radius, right? That means you just two particles are basically near each other. So the other one we want to use is filter positions by relative contrast, which going to check these filter positions, right? That will remove some of the noisy pickings, like ice contaminates or the edge of the membrane of the cell, edge of the hole. So something like that. And the particle detection threshold, which is also an important parameter, control how many particles you want finally output from the auto picking or like size-based picking method. Here we're going to set as 1.5. So basically that's everything you want to change for this method. Save it. You can run it. So we can run B5 preprocessing, sorry, maybe a different name for you. So you need to pay attention is 10.499 preprocessing job, which for me is like a B5 preprocessing, right? And start running. So you already finished this, yeah, we just made right. So the 10987 neural network picking method finished. We can go to this blog and try to find whether the picking is good or not. Open it. Well, this is the first tomograph we see. So this tomograph picked 504 particles with the neural network picking method. If the training that you have is properly working, like it should pick the right things, right? So if we go different slices, basically it's picking the right thing, right? Like the ribosome that we want to pick, those ones. There may be something like on this membrane contrast, I guess, but it depends on the the training that you have or the parameters you change. So some ribosomes may be very close to the membrane, so that makes sense because in the cell it happens. But most the position looks good. All right. I think we're gonna wrap out this neural network picking. We're gonna go. We won't be paying attention to this again. So while this SASTA-based picking is running, we can go to the next. It's like a geometry-based picking method. So this one, you can open it. Well, maybe because we just changed some parameters and then the display is showing a little difference, but it shouldn't affect anything. So you open it in the reconstruction panel. Here we're gonna pick the vision, and also we pick the positions around surrounding the vision. So the first thing we need to do is measure the vision size. So 900 angstrom, this one, 900. Whether we are in the right position now, we got the central slice of the vision. Yeah, they are about 1000 angstrom or like 900 angstrom, so that should be okay. So that's the only thing we only need to pay attention. So we're gonna go back to the panel and try to edit. So the one we want to use is particle detection method, right? Go to the particle detection. We're going to use detection radius here because we're going to pick the spike surrounding surface of the virion. We just give it a radius. This radius I cannot measure on the the virion panel, but you probably have the particle radius if you have a kind of your own interested target. So, and the detection method we're going to use. Oh, we don't need to change here, actually. Yeah, there's nothing you need to change here. We go to the virion spike detection. This one, this panel. So the virion radius we just measured, because we measured the dimension, we just use like a 500. Let's open this node again, so so you can see. So 500 angstrom is virion radius we're going to use. And the virion detection method we're going to use is auto. So this is the one that's actually doing the geometry based, do the virion picking with automatically. If we pick the particles surrounding the virion, which is related to the spike detection method, we can do the uniform because we pick everything uniformly surrounding the surface of the virion. It's a uniform method. We're going to change the minimum distance between the spikes as 10 voxels. Of course, in the real case, you're going to calculate the voxels distance of the particles that you have your own case. But here we're going to set it as 8. The size of the equatorial band to restrict spike picking, which is this parameter, control how you're going to pick the spike particles or the particles around the surface of the virion. Like if we see a sphere like this, the bandwidth is like equatorial from the central of the sphere, go up and then down. The distance between between the center and the two barrier layer of the sphere. And so we said as 800 means we can basically keep the whole sphere volume to pick the whole sphere of the virion. If you set a smaller value means you only restrict the picking area on a smaller band surrounding the sphere. So 800 means we pick everything. We want everything. This basically control that when you have a data sets have some strong like a missing wedge problem, a top and the bottom of the virion, you don't want to include for the refinements, you can use this method to restrict the positions that you want to pick surrounding the sphere. So that's everything I think we should change for this method. Save it and run it. So this one is 10.164. We only want to run that. Okay. All right. So the 10.499 size-based picking finished. We can check that. Looks good, right? Like showing they are picking the right size we gave it. And most of the positions should be the drop sum. If you go through the different slices, you can notice that there's nothing picked here, even though there could be some signals very close to the size we gave it. All right, there's nothing here also. So there probably is something that looks good also, I think. Yeah, maybe there's some drop sums outside of cell. Yeah. All right. So everything looks good for this data set and method. So we're gonna finish this one also. While this geometry search is method picking is still running. Okay, it's doing the right thing, I think. I think that's the last thing we need to wait and to see if it does. All right. There's something else I should mention. Should be. All right, just trying to do the thing. We can follow the streams log information to check whether everything is really working.
Maybe while you wait, there are some questions here that
yeah, sure.
Try to answer.
Yeah,
somebody is asking how many particles were used to train the model that was shared with the participants?
Yeah, good question. Yeah, for the training, as our method, we only use like a few particles for the training to work properly. So the general idea that you can have is that from 3 or 2 tomographs you can pick total number of particles as 50 to 100 maybe. But if you want to improve the kind of training model, you can pick more. Nobody stop it, but 50 to 100 should be enough to for a properly working model to pick properly the target that you want. So yeah, that's the general idea that you can keep in mind. Yeah.
Great, thanks. There is another question, says, is the minimum distance between neighboring spikes measured from their centers or from their boundaries?
Oh, see, I think the center. You mean this one, right? The minimum distance between particles, is that the one?
Yeah, I think this is referring to maybe to 164, but yeah, it should be the same parameter.
Oh, I see. I think for this matter is the center, and then the.
Okay, sorry. Yeah, it's a different parameter. You can go ahead.
Oh, okay, all right. So the spike detection in this method, the mean distance between spikes is also like control the how sparsely that your particle is gonna pick. This is also like a center. So you measure the distance between the possible positions you're interested in by voxel values. Of course, it's a binned tomograph voxel values. Yeah, you have to calculate that in a proper way. So yeah, it's like center distance.
Okay, thanks.
All right. Yeah, I think this is working. Like see, there's a warning. It doesn't matter. Warning just give you something awareness, like something's happen. Yeah, it doesn't mean that bad things happen. Yeah, just ignore it. All right, something showing up. We can get open. Right, that looks good. We can close these auto spikes right now to see whether the variance looks good or not. Right, so the spheres are picked in the right place. I think that looks good. So you're gonna find that most of the the radius of the green circles, they're just sphere, right, surrounding the actual variant, but it's not really the surface we're trying to pick, because we use segmentation method. We only pick the surface, which you're gonna see this here, the surface surrounding the actual variant shape. It's not the green circle. So that's thing you need to keep in mind. And you can show the particles. So you can notice the blue circles surrounding this sphere is really not matching the green circle, because it's matching the actual size, the shape of the beer. All right. So since they finished, there's another thing that we can go through is if you want to remove some variants that really not you want the shape maybe is not actual variant, or maybe it's just like photo parts variants that you don't want to include for the next step for the refinement. So we're going to demonstrate this step right now, but we pay attention to this. We are not going to run this really, because you're gonna affect the next step, the particle number you have. So we are not going to run this actually. We are gonna just show it to let you know that you have step to option of this to do this. Yeah. So the thing that you can do is when there's a variant you want to remove, you can go through this segmentation panel, go through all of them, check whether the variant you don't want. This is a perfect example, right? So this is like a fall apart protein, like it's not really severe anymore. So you don't want to use this. You can choose the last column to discard this variant for the picking. So I didn't mention the other columns selection. I think you may already know from the yesterday's session that those columns is just setting the threshold you want to use for the surface match uniform picking. So this yellow circle is surrounding different positions of the variants by a different threshold. So you can choose different threshold, say, yeah, like this. But right now we keep it as default as 1. So all the default threshold will be the first column. We won't change this for everything. So that's I just show you how to remove those variants. To actually remove those positions, you need to make it like a runnable for this block and run it. Please don't run it right now because you will get different number of particles. Oh, sorry, I need to check this. The resources we have. And I can notice that we get 14,244 particles, which kind of a little difference, I think, from the assay package we should be, but I'm not sure this really going to work for the next refinement because we have a templates to make it refinement faster, where you don't need to search all the range of the angles to do the reconstruction properly. So we have to see.
I think that's going to be fine. We can
all right.
figure that out within the break. Maybe before closing in, because we have like 1 minute left. There's one question about whether filament picking is included anywhere, and like a follow-up to that is there a way to export tomograms for picking externally and then import the coordinates?
Oh yeah, I think that's a good question. Like because it's pretty. I think yeah, you can do that. Maybe you can do it with the interface. I guess you can download it. You can download the tomograms right from here, or you can, if you have terminal, you can go to the path of this project and access all the tomograms reconstructions from the path you have. So of course you can pick particle positions from the tomogram different with a different method, like the other packages, and we provide a way to import the particle coordinates from other sources. Like the thing you need to do is like change the detection method as import. Here you're gonna see the settings that you need to do the include the path where you want to search the coordinates. So you probably need to change the name of the coordinates you have from the other packages like modes or I'm not sure other dynamo, I guess. Use the modes command to convert those TXT files to the mode file, which is mode conventional format, and rename the coordinates extension as spk.spk, right? So that will run. So that is this function or this like a panel will recognize those coordinates properly, and then save it and run this block. It should import properly your external coordinates generated by the other package. So once that loaded or running finished, there will be some kind of auto particles list labeled here. Should be the one import coordinates. You need to go through all those classes, whether those import coordinates matching the real tomographs you have right now. If you want to use that imported particles as a input for the training, actually there's a trick which also discussed in the GitHub discussion panel. You can check that. But here, if you want to use that imported particles as a training set, as an input, you can copy this to a different name, like a training pick. Copy. Then you can use this list in the next step. Let's say you want to training this, maybe this one. Probably that's too much, sorry. You want to change the train and find your list, right? This train pick list. That's the way how you're going to import particles from the external way and then use that import particle as a training set. I think that's it.
Yeah, okay, great. I think, yeah, we're a little bit over time, so we should take a break now. And then we'll be back at 10:40. That's in about 7 minutes. But thank you, yeah, very much. And then we'll continue shortly. Thank you all very much.